Good morning and welcome to IPC Apex Expo here in San Diego. We're broadcasting live from the show floor and delighted to be bringing you quite an extensive program this week of different presentations, panel discussions, and talk shows. We're going to try and bring you some pictures and images of the show floor itself so you'll be able to see some of the action going on. We'll also be bringing you some other interviews from my two co-presenters who are joining me today. I have Keith Bryant and Mike Konrad. So welcome, guys. Nice to see you.
Nice to see you too.
Yep. I think we have to say it's good to be here in person.
Yeah,
incredibly.
It's always nice to see people, not pixels. So.
I know. So it's going to be a very different show this year, obviously because of the pandemic. But I think it's fair to say that IPC have been pretty good at making sure, checking everybody's got their vaccinations and things like that, and are doing good practice. I know we're not wearing masks for the interview here, but everybody else is around the rest of the show floor.
Yeah, they've got the COVID stuff, I think, covered really well. They're doing checks on everybody for vaccinations or tests and all the other stuff. And as you say, thankfully, I guess because it's not a huge show, the aisles are wider and there's more space. And, I think everybody is as safe here as you could be at an expo.
Yeah, we have our white wristbands to prove it. Yeah. I feel like I've gained entry to a exclusive nightclub or something.
So the white wristbands, of course, denote that you've got all your jabs. I see Keith's got a green one on, as I've got a green one on this arm, which is another traffic light system they've got here. So red means don't come near me. Yep. Amber means that you can do
we can touch
elbows or fist bumps, and green means you'll do handshakes and hugs and kisses
and high fives and anything you get paid for, basically.
Yeah. I'm not wearing one. I want to be ambiguous.
You want to be ambiguous?
Yeah, so people have to take their chances with me.
Excellent. Okay, well, as I say, I think they're taking all the precautions they possibly can, and it's going to be a very interesting, and it feels a fairly safe environment, quite frankly. So let's talk a little bit about the shows you've got coming up. Let's start off with you, first of all, Keith. You're doing the Keith Bryant show. Tell you, what time are you on this morning?
12:30.
12:30. Okay.
Yep. And 11:30 tomorrow, I believe.
Okay.
Yeah.
So what's coming up?
Yeah, well, we've got everything from new stuff about SPI, some, let's say, material treatments with what they're calling nanospec surface treatments, right through to a new wave solder machine and new stencil cleaning stuff.
Right.
And a couple of other guests that I'm still trying to line up at the last minute. So, yeah, it should be an interesting and varied program. Hopefully we'll have some good conversation.
Right, excellent. And Mike, you've got some guests coming on. You're branding it under your Reliability Matters.
Yes. Yeah, thanks for inviting me to produce a couple of the shows here in your booth, your impressive booth. We'll be talking to three people tomorrow at 1 o'clock. Today at 1 o'clock. At 1 o'clock. From Viscom, we'll talk to Jesper Leik and Ed Moll about inspection systems, specifically one of their inspection systems. And that's always a subject that interests me from a reliability standpoint.
Yeah,
because it's better to find it in the factory than have it escape out to
into the field. Yeah.
And then we'll also be talking to Kevin Hill at EM Solutions about quick turn assembly. And on a similar subject, we'll be talking to Greg Papandrew from PCB Direct, who is a board broker, basically. He is responsible for obtaining circuit boards. And since the entire foundation of everything we do starts with a circuit board, it's an interesting conversation. He's helping me at SMTA produce a training series on how to purchase boards, best practices for purchasing boards. So we're putting that together right now. So he'll give a little preview of what SMTA members can expect from that.
Right. I'm sure he must be going through some real issues at the moment with all these supply chain issues we've got out there.
Supply chain, tariffs, transportation. I'm sure half his products is sitting just a few miles north of us, out in the ocean right now.
Right, exactly. Okay, so looks like we've got a busy day ahead of us. So I'm going to let you two go off and basically get ready for your shows later on today. And coming up after the break, I'm going to be joining my first guest of the day, and he's coming in remotely from the UK. We'll be joining Michael Ford from Aegis Corporation. Okay, and welcome back. So joining me as my first guest today is Michael Ford from Aegis Corporation over in the UK. Welcome, Michael. Nice to see you. That's a familiar sight.
Hey, nice to be here.
Your home office. So it's just a pity you couldn't make it over here to San Diego, but that's life.
Yeah, I'm gutted.
Sorry?
I'm gutted. I'd have loved to have been there.
Yeah, I'm sure. But you actually had a lot of input to the show here because you've been very involved in the Factory of the Future. And I'm just wondering what people can expect from the Factory of the Future feature that we've got at the show here. How much can you tell us about what's going on in that area?
Yeah, there's a whole team of people behind the scenes putting the conference together, most of them volunteers, I should say. And it's been quite interesting putting forward, the idea of Factory of the Future, because, I think most people are quite concerned with the factory of now and, getting through all of the situation with COVID and supply chains, etc. But, the Factory of the Future, achieve digital transcendence. It was really an idea that IPC had to look forward, let's say 5 or 10 years, and to work out what kinds of technologies that we would be seeing in manufacturing. I mean, in terms of machine processors, maybe new kind of PCBs, flexible or wearables, and of course the software side, artificial intelligence and the role that that may play in that factory. So we really wanted to have a glimpse into the future so that we could start being, a form of guidance, if you like, with the industry, really to set that kind of roadmap towards this digital manufacturing of the future. Right.
Okay. Interesting. I had a discussion yesterday, an interview yesterday with Chris Mitchell from IPC, and he was saying that in the rollout of Industry 4.0 automation adoption, he said that there seemed to be some real disparities between different geographical regions. For example, he felt that Switzerland, France, Germany were very progressive in their attempts to bring in more advanced factory automation and line automation, whereas in the United States it was a little bit subdued. I think the big companies, the tier ones, of course, they're obviously getting involved in it, but it's a bit of a harder sell for the smaller companies over here.
Yeah, it's always difficult to understand, am I going to be on the bleeding edge? I want to be the leading edge, but right. There is always a risk that it carries. And we've seen that getting to understand how to collect data, what to do with that data, and also then how to secure the data so that it's only used for good, can be a daunting thing and requires time and investment. So, those who have taken the plunge, as it were, they've been motivated from a specific point, the need for something. And that need for something varies from company to company, product line to product line, sector to sector, whether you need traceability or whether you need to work in a very strange environment, for example, where normal kind of techniques wouldn't work anymore, whether you've been facing with the need for agility, high mix environment. So yeah, different people do see different pressures.
Right. And talking about the topic of security, I mean, there's obviously you're driving forward the IPC initiatives on counterfeit, avoidance. What new things have been coming out on that?
It's an interesting area because, even starting with the design data, for example, normally when a product would be re-engineered by a competitor or whoever, it would be physically out in the market and it would take weeks or months to do that. In the digital realm, you could use minutes to actually take some file and start to understand the technology and the IP within that design. It's very, very much more important to secure it. And so what we've been looking at are many different standards actually from IPC that allow a kind of interoperability of information in a secure way. So first of all, with IPC 2581, we now call him DPMX, having that one file that represents the digital product model of that product you're going to make, using Connected Factory Exchange, CFX, to securely transfer it over the internet into the factory for use, even down to the machine level.
Right.
We also have the new IPC cybersecurity standard on the horizon. This is not just regular IT cybersecurity. This is actually practical manufacturing-driven cybersecurity. What happens on the OT network where something is discovered that may potentially affect products? And so there is a full range of help and instruction and procedures defined within that in order to ensure that products are not compromised in any way. Right. So that together with the traceability, that association of materials and products, good for the whole supply chain security, authentication, creating digital fingerprints of products and materials as they're used. Right. These are all covered now in these new IPC standards.
Right. So when can we expect to see them being rolled out? I mean, what's the time frame for them?
The new ones, cybersecurity is pretty much imminent. That's going to be probably the first half of 22. The 1782A secure supply chain is already out and is in fact adopted by the US DoD, which is nice. The next stage of that, the digital fingerprint, this component level authentication, it's probably going to be quite a few more months before that's taken out. Other things like, of course, CFX is already out there, the IPC digital twin, and 1782 base traceability, already out there and good to go. 2581 celebrating 10 years, I think, right now. Or is it the consortium that's celebrating 10 years? So it's very much an established standard.
Right. Excellent. Okay. And you touched on there, of course, the digital twin, which is a very important development for being able to get boards into production and much quicker with fewer turns and things like that. You're saying is that available now? Is that actually?
Yes, it is. And yeah. The idea behind it is really to form the structure of interoperability. So, for example, and this was released last year. For example, you can define the digital twin of the product, of materials, of the bill of materials, of your production line configuration, the machines themselves, your assignment of products to lines, the products as they go out into the market. And so that's a massive scope. And so what we wanted to do is to create the interoperability. How should market data interact with manufacturing data, interact with design data? Because there's a lot to learn if you're designing your next product and you want to understand the manufacturing environment, you want to understand past performance, etc. So creating that interoperability is the most important thing. And that's what we set out to define initially in this digital twin standard, so that we're not forcing people to use any particular solution. Of course, that's not what IPC do. What we're doing instead is to create that framework where you could have a dozen different solutions, all being able to talk to each other and interrelate each other, providing data, sharing data, so as to build this holistic digital view of the entire manufacturing chain from design, manufacturing, and out into the market.
Yeah, well, it's fascinating stuff, and it's certainly, very, very, very timely at the moment. But Michael, it's great to see you again, and I want to thank you for coming and joining us. It must be kind of getting late in the day, I guess. Over
it's dark outside. I wish I was there. Honestly, I'm missing all of the fun there.
You are, and we're going to try and bring you some shots of the actual show floor later in the day. So we'll be doing that as well. But for now, I've got to say thanks for joining us. And coming up after the break, we are going to be talking to a representative from a brand new company that was launched only 2 weeks ago.
Wow.
Electronics are part of our world, expanding by application to open up new opportunities for automotive, healthcare, and many other industries. But today's manufacturing techniques are not sustainable. They are energy hungry and inefficient, expensive, and have limited flexibility. The world is asking us to do better. Introducing PulseForge tools, a new approach to thermal processes like soldering and curing. Design with more flexibility, manufacture with fewer process steps, reduce energy use, and decarbonize the supply chain. Expand your creativity to new levels. Designers are asking for more. They need to reduce form factors, reduce weight to work on wearables and stretchables, opening new market opportunities for consumers across the world, asking us to do better. If you think sustainability and freedom of design are not possible in electronics manufacturing, think again. Think PulseForge.
And welcome back. I'm delighted to be joined now by Stan Farnsworth from a new company called PulseForge. Welcome, Stan, and thank you for coming in today.
Of course, good morning. This is our debut here at IPC Apex, following our exciting launch at CES just a couple of weeks ago.
Right, exactly. So just to explain to our viewers, the PulseForge is a breakaway division from Novacentrics. They were together at one point, but explain why you split the company.
Sure. So Novacentrics is our origination point. Novacentrics has been in operation altogether now for over 20 years. We started as a nanomaterials company, evolved into printed and flexible electronics, and over the course of that evolution, we developed a couple of really important business units. One related to materials through primarily electrically conductive inks, and also some continued sales and development of nano powders and formulations. But the second one that really developed as we got more into the challenges of printed and flexible electronics is related to processing those materials. And the challenge has always been processing materials at higher temperatures than what their substrates could accommodate. And that seems like a challenge for sure, but we figured out how to do that with our PulseForge tools. Mm-hmm. And over the course of time, the PulseForge product line has evolved, and we finally realized just during the pandemic that we wanted to separate that into an independent entity to really let that blossom and flourish. And so here we are now with Novacentrics continuing on, but here we are today with PulseForge Corp.
Great. So tell us a little bit how the technology works, because you mentioned there that it reflows solder and other materials at a much higher temperature. But of course, that normally sends warning bells off in people's minds, but in actual fact, it's a very safe system, for the components around it. Maybe you could explain that.
Of course, thanks. We are playing tricks with heat transfer. Mm-hmm. So using physics in our favor, it turns out that if we can apply energy quickly enough, and by quickly enough, I mean seconds or even milliseconds, then we can achieve the target temperatures on the, in this case, the solder, and achieve liquidus and get good reflow properties, but turn off the power again before enough total energy has been applied to heat the substrate and the components. So we're heating only the solder in seconds or less, and not heating the entire body of the substrate and all of the other components. And in doing that, it lets us do a couple of things, and it lets our customers who are using the tools do a couple of things. It lets them process the solders very quickly, much faster than traditional technologies allow. It lets them process large areas altogether, so we get much more scalability and throughput. And when you process large areas, you get fun effects like self-aligning components, because the surface tensions on the solder allow them to realign themselves on the pads, which is really exciting to watch. But really importantly also, it lets us and our customers use only about 15% of the energy that a normal reflow oven would use. And so it's a great way to decarbonize the supply chain and save some energy costs while we're at it.
Yeah, that's incredible, because, I mean, sustainability is such a big deal nowadays. A lot of countries are mandating that you have to reduce your energy levels. So this would be certainly one way of being able to reduce energy levels in the factory considerably.
Yeah, absolutely. And a quick tool installation, that's a very quick way to drop energy consumption. Because of the technology, there's no need to turn it on hours early to reach thermal equilibration in 10 or 12 zones. The way we're delivering the energy through light energy, it just turns on and then it turns off. It's really that quick.
What temperatures does it get up to?
So we can really readily achieve the liquidus temperature of even SAC 305. The lead-free solder is no problem at all, 200 to 300 degrees, 250 degrees C. In other applications outside of soldering, the tools that are configured for these other applications can do really crazy things like even melt glass frit. In fractions of a second, so 1,000 degrees C plus.
Wow.
Now, of course, we're not doing that on the electronics side, but the tool capabilities are certainly there.
Wow, that really is quite a very flexible range then of different applications. So, I was lucky enough to be with you up at CES to have a look at some of the things that were going on there. And I spoke to Rudy Gosch about one of the applications we were talking about, which was really how to reflow onto materials, and wearables. Maybe take a look and see what Rudy told us. So one of the areas that seems to have attracted a lot of attention this week is on the wearable side.
Absolutely.
So how do you photonically solder onto wearable materials which are stretchable?
So that's, again, a great question, and this has come up multiple times with a lot of the customers that we have talked to, right? The samples that we are showing here are very thin PET. It's very, very flexible, but it's not stretchable, right? So for a lot of the things that we would work on the fabric side, on the wearable side, let's say, would need to stretch a lot more. The substrate would be something like TPU, thermoplastic polyurethane, and instead there is definitely a down the line possibility of having, etched copper on TPU. That's not what we have right now. But what we do on the Novacentric side of our business, we have conductive inks.
Right.
And those conductive inks, by controlling the property of those, you can really make them stretchable. Now these stretchable inks can then be cured using the PulseForge technology. So you can put down SAC 305 and do the solder reflow using our PulseForge technology.
Yeah, so it's clear there, Stan, that what's happening is that they're using the combination of the PulseForge tool and, in this case, for the wearables, working on the Novacentrics inks that allow that to happen.
Yeah, and that's a really key point. Certainly the tools are dependent on having materials to process. The good news is that really almost any material can be fine. So Novacentrics has very excellent inks, and of course we'll advocate for Novacentrics inks. But we're finding that there's a lot of adaptability in the tools as well for different types of solder from many of the manufacturers. So we've been partnering and doing tests with leading manufacturers, solder providers here in this room today. We've done some publications with Indium and a couple of other folks as well, for example, using their off-the-shelf solder. So it doesn't require a special material to be able to use this new technology.
Right. Well, okay, so when I was at CES, I also asked Rudy about some of the other applications that opened up for this technology. And this is what he said. Just finishing off on the low temp solder side, that it is a real alternative, because some of the options they're looking at the moment are tin bismuth alloys or potentially ECAs, which, of course, they use silver flakes, which is expensive.
Yeah, and there's, I'm not going to say anything that is inherently bad about those technologies, but those are being used because you cannot use the more conventional solder alloys such as SAC 305. And why cannot you use SAC 305 for a lot of these new applications, right? Because SAC 305, the reflow temperature is much higher than tin bismuth. We had some of these samples here where we show what happens to PET.
Right.
Very thin PET, you put it in an oven, it gets completely destroyed. We have a way of getting around that. So now you don't have to think about using silver epoxy. You don't have to think about ECAs, ECPs. You don't have to think about using tin bismuth. You do not have to make a sacrifice in your performance. You do not have to make a sacrifice in terms of materials that you use just because you want to design and develop new applications.
Yeah, well, of course, that clip there was actually talking about the using the tool as an alternative for low temperature soldering, which is obviously another key application for it. But Stan, I mean, you found some great applications when you were at CES. I think the one that sticks out in my mind was the guy from WAGS. Tell us a little bit about that.
Well, we loved CES. That was such a great venue for us to debut the company in the consumer electronics space because of the tremendous design that's evident there. And of course, CES is well known for that. One of the things that we learned at CES this year was the tremendous growth of wearables for animals, for pets. And we had an opportunity to talk with the good folks at WAGS. Tom Mason is their chief supply chain officer, and he spent a few minutes with us talking about the need for getting improved form factors, smaller devices, reduced weight, so that they could actually develop products for smaller animals. Right now, they're constrained only for larger 15-pound plus animals, dogs, large cats, I suppose, and the ability to have smaller, lighter form factors would enable a whole additional market segment for them with their pet wearables.
Absolutely. I mean, it's into the toy dog market and everything. So that really would open up the market for them. So, yeah, a lot of interesting applications, and I think this has got a long way to go. So we're going to keep a very close eye on it, Stan, and we'll be having a further interview with you later in the week, which we'll be recording. But for now, I want to thank you for coming in and joining us.
Thank you very much. Nice to see you.
Okay. So coming up, there's a couple of interviews I recorded yesterday with the IPC staff, notably John Mitchell, who's the president, and Chris Mitchell, who's head of government relations. So we'll be passing over to the first of these interviews now.
At Kaizen, we know it's the science that makes the difference. The right solutions happen when you care enough to ask the right questions. And we understand that your performance is directly related to ours. Science knows why it works, care knows why it's important. For micro dispensing, there is one product line that is proven and trusted by manufacturers in semiconductor packaging, electronics assembly, medical device, and electromechanical assembly the world over. DL Technology, superior pumps and needles for the finer things in life.